All right, so let me just share the desktop here. All right. So we ended basically with this idea at the firm level. Take note that there are multiple firms. So the idea is all of the different firms will set their demand for labor according to this. And then the wages, since there's only the one W, will be equated over all of the firms in the market or in the country, right? In the macroeconomy. So you can imagine price times MPL will be equalized for all the firms in the economy. For all price times MPL will be equalized for all the firms in the economy because all of the everyone will have the same wage. If the wage for one company is bigger than another company's, then labor will just transfer to the company with a larger wage. So therefore, you expect at the equilibrium there will be an equality in the wage rate. The prices, however, don't need to be the same, especially if you have different prices for different output prices, different goods, right? So you can imagine P times MPL will be different per firm, per industry. But if labor was homogeneous, then there would be a single wage rate being equated between all of the different industries as labor will jump from one industry to the next. All right. And then, of course, if W and P were both homogeneous or just one price or just one W, then you can do this transformation and then you can expect that all firms in the economy will have the same marginal product of labor. All right. The same is true for capital. And if there's literally only one output and then the same and capital is homogeneous, can move from one industry to the next, then you expect the marginal product of capital to be the same for all firms. Our next issue is the division of national income. So you'll notice that economic profit is simply the difference between real GDP and the share of income or the amount of income that goes to labor and the amount of income that goes to capital, right? That's economic profit. However, because it's constant returns to scale, we can show through the Euler's theorem that the total output here will exactly be equal to the amount given to capital and the amount of income given to labor here. And you can see that through this mathematical note, if you use Euler's theorem, given constant returns to scale. So normally then you would think that profit would simply be economic profit plus the return to capital here or the income of capital here. So that's what we would call accounting profit. And like we said, if it is CRS, then what we would call profit for capital for the capitalist, the firm owners will be equal to MPK times K. This would also allow us to understand or to connect it to the fact that most capital owners are in fact the owners of the firms as well. So that's why the accounting profit for the firms will essentially equal the margin, the return or the share of income or the component of income that goes to capital. Okay. So this is a very interesting case study. It will help you understand marginal product of labor and capital and its effect on factor prices because the Black Death changed the supply of inputs. You would expect it to change the real wages and real return to capital. So here we've got a very basic production function, which is called the Cobb-Douglas production function. I'm looking for, here we go. This is the Cobb-Douglas production function itself, where A is, this capital A is technology. K and L, of course, are the inputs, and alpha and 1 minus alpha are the exponents to K and L, respectively. Alpha is a positive number and will be less than 1 as well, right? All right. So in this case, because you wanted to, well, the context in the United States is that the division of income between capital and labor has been constant for a long period of time. Therefore, the share of capital income to output and labor income to output should be constant. And that's where the Cobb-Douglas production function comes from, where these alphas and 1 minus alphas are the share of capital and labor, share of income of capital and labor is constant at alpha and 1 minus alpha. And here you have capital income being MPK times K, right? And then labor income being MPL times L. And it's a constant share of output and a constant share of output here. So that's the key. And this becomes the Cobb-Douglas production function. There is a graph here that basically supports the notion that on average, the labor share in the United States is constant. And that's what motivated the use of the Cobb-Douglas production function. All right. So having said that, we will first check that the Cobb-Douglas production function has constant returns to scale. And yes, it's true. If you were to apply the z here, then it must be that the left-hand side will equal the right-hand side. And after you simplify terms, then you'll see that, in fact, it's z times the original production function here. So that's why it's just z times y. After bumping up k and l by z, after simplification, it's simply you're bumping up y itself by z. And the secret here and the key is that it's because alpha and then 1 minus alpha, that sums to 1. So that's the idea here. So the exponents for z here, z alpha and z 1 minus alpha, that sums to 1. It becomes z raised to 1. Next, and this is something you should all know, that the marginal product of labor by using differentiation is this, and the marginal product of capital is this for the Cobb-Douglas production function. And you will see that the marginal products of the Cobb-Douglas production function can be written as follows. So the above here is essentially the same as this. So MPL is 1 minus alpha y over L. And then MPK equals alpha y times K, right? So notice that it is true. For example, MPL times L equals 1 minus alpha y, and MPK times K equals alpha y, right? So that corresponds to the original motivation for Cobb-Douglas, that the income of labor is just a fixed share of output. The income for capital is just a fixed share of output. But the other thing that Cobb-Douglas gives you is that the marginal product of labor will just be 1 minus alpha y over L, and the marginal product of capital will be alpha times y over K. Now, of course, the 1 minus alpha is the labor share, right? Labor share. And then alpha is just the capital share, the share of capital's income in GDP. The other thing you should think about here is what is the interpretation of y over L and k over L. So y over L, that is called output per worker. It's also called average labor productivity. And y over k is called average capital productivity. So what this is showing you is that marginal product of labor is proportional or related to this thing called average labor productivity. And marginal product of capital is proportional to average capital productivity. And by proportional, we mean that it's, if Cobb-Douglas is correct, it's exactly equal to 1 minus alpha, which is the labor share in GDP, times average labor productivity for marginal product. So here you can verify that if factors earn their marginal products, then the parameter alpha tells us how much income goes to labor. And then 1 minus alpha goes to capital. Okay? The total amount paid to labor, which is MPL times L, equals 1 minus alpha Y. And therefore, 1 minus alpha is the capital share of output. The same thing for, 1 minus alpha is labor share of output. Similarly, alpha is the capital share of output. And the ratio of labor to capital income is constant, 1 minus alpha over alpha. So we've shown this data here, which shows that the labor share for the United States is constant. All right. So moving forward, you should know how to derive these things using or manipulate the Cobb-Douglas production function to arrive at these equations here and to arrive at these relationships here. So labor productivity as a key determinant of real wages. You have seen that MPL is essentially proportional to labor productivity. And you've also seen that MPL is related to real wages. So therefore, there has to be a connection between labor productivity and real wages. Okay? So here in table 3-1, you do see this productivity, labor productivity and real wages connection. So the higher the labor productivity is, the higher the real wages ought to be. Okay, so that's data from the United States of America. I will encourage everyone to download the following data. So here, I'm just going to show everyone. The PSA has the wage share in domestic product. So this should correspond to the wage share in GDP. Unfortunately, this is a highly contested figure because this wage share is based simply on compensation of employees. Whereas we know that there is a large informal sector in the Philippines, and therefore a lot of those informal firms are 1 or 2 person companies, right? And therefore those people might or should really be in the wage category. So a lot of people are saying that this data here underestimates the actual labor share, right? You can also see that fact because here, right, in the United States, the share is closer to 0.7% or 0.7, right? Whereas in the Philippines, based solely on this compensation of employees figure, it's 25 to 30%. Okay. Of course, the other thing here that I should be excited to share with you is that the data between 2009 and before 2009, after 2009 and after and before 2009, according to these metadata facts or footnotes, they're not strictly comparable. So there is a way, there is, for the people who are interested in macroeconomics and this distribution of GDP or income across the different factors of production, then there's space for further research here. And if there's anyone who would be interested in this topic moving forward, I would be happy to help you guys push to show you some papers and some work to sort of update the Philippines data here on the wage share. Okay. But just for this class, I just want to show you that the Philippines sort of half-heartedly is trying to compute the wage share, which corresponds exactly to our theoretical discussion here in Cobb-Douglas, which is the labor share is this 1 minus alpha. Okay. Now that's highly contested, of course. Then I would also suggest to everyone, here you have indicators derived from the national accounts. Again, I challenge you guys to look for this at the PSA's website. And then labor productivity is available for the Philippines. And we can plot that. What is interesting is broadly labor productivity is rising. However, since the 2014 period or 2015 period, labor productivity has essentially stalled here. And I invite you guys to download this. This will come into play later in the next week after when we go to chapter 4, right? Because labor productivity, just to return to this thing, right? This is labor productivity and it's related to the marginal product of labor. And we note that the marginal product of labor is related to the marginal product related to the real wage here, right? So one of the most important facts or statistics in the economy really is labor productivity, and it's super super important to relate this labor productivity figure to compensation for labor in the Philippines. Yeah. Then you can also strive to grab statistics for the real wage. So again, this is a highly contested figure, this real wage figure, and there are examples or different series because there are different industries, so therefore the real wage is expected to be different. So you can expect to find different labor or wage series or real wage series, right, in the PSA. So this is one of them. This is the average real daily basic pay, and then it's plotted between 2001 to 2018. So what's interesting here is that after you do so, what I've done here is to normalize this to 1, such that 2001 is equal to 1. And what you can see here is this blue line. This blue line is essentially flat for the real basic salary. So what that means is that in 2018, it's higher than it was in 2001, but not by much. However, this GDP per labor normalized, this just comes from the earlier plot here on labor productivity, which again, I encourage everyone to download. As you can see, relative to 1, I've normalized 2001 to 1. Labor productivity overall has gone up to 1.8. So, unfortunately, in the Philippines, right? Unfortunately, in the Philippines, there seems to be this wedge between the average daily basic measures of real wages and measures of labor productivity. Again, if this is something that's interesting to you, right? This is something that is not predicted by the neoclassical model, although there's literature that sorts of tries to not figure it out, but to structurally estimate what's going on, right, in the Philippine economy. If this is something that's interesting to you, please talk to me about that. And I should go back to this wage share. Like I said, you should try to look at 2008 to 1995. And here the wage share is essentially constant, okay, which corresponds to the constancy of this one, right? Of the real wage. But the weird thing is labor productivity is in fact rising, right? So if labor productivity is rising and the labor share is constant, then you would expect that the real wage would also track basically the behavior of labor productivity. Unfortunately, given this particular real wage series, it does not. And it's an open question in the Philippines, I think. Generally speaking, looking at all of the different real wage or labor returns to labor salary, whether labor productivity is in fact tracking or is robustly related to these different measures of real wages. Okay, so having said all of that, we're done with the distribution of income. And what's next in class is what I wanted to talk about next is the difference or what determines the demand for goods and services. So when we meet in class, we will be talking about 3-3 here, which finally says, okay, here's your GDP. Why? GDP is divided to the different factors of production. But now we will expand the discussion to how that GDP or Y is divided amongst C, I, G, and NX. And like I promised, at the end of it, we will be talking about, again, in the context of this particular model, the story of the butler, right? We will understand what might happen to national income given in based on the facts of the story of the married butler. All right, thank you. Bye-bye.